Hello, today we are going to talk about the programming language JavaFX Script. This is the way how it looks like. This is the result of running the JavaFX script. Or you can use Java source code. So this is another programming language, it's called JavaFX Script, and this is the programming language Java. This is actually a Swing application. I'm not sure why it's here in this wiki page. Okay, so there's namespaces or packages JavaFX, stage and scene. There's a stage. There's a scene named scene lowercase s, and the type is uppercase s. And then similar to JSON, there's member name and member value, pairs of name and value, identifier and value. So this is an integer identifier, this is a string member. This is an object. This is a type font. This is a member named font. And this is its value. Okay. So this programming language was first released with JavaFX 1 in December 4th, 2008, and it disappeared in 2010 when Oracle announced that it would stop using the programming language JavaFX Script, and starting with JavaFX 2, the only way to write JavaFX applications is using the languages that can already run on the Java virtual machine. Okay, so from 2008 to 2010, and the versions are 1.0, 1.1, 1.2, and 1.3. Okay, so let's start by looking on Wikipedia about JavaFX. So JavaFX is a platform. It consists of a number of Java classes, Java packages, Java jars probably. And right now the project is called OpenJFX, intended to replace Swing as the standard GUI library for Java. In JDK 11, JavaFX is part of the OpenJDK, and already in Java JDK 8, JavaFX is built into Java JDK 8. Okay, so Swing is intended for desktop applications. It tries to mimic the style of desktop mouse pointer window click standard applications, whereas JavaFX is made to be GPU efficient, to use a GPU, to be resizable, rescalable. So similar to what at the moment were available as RIA. At that moment, Microsoft Silverlight was a technology that seemed to have a bright future. It could run inside of the web browser as a plugin similar to Flash Player. It could run outside of the web browser as a desktop application. It was intended for rich web applications, and the competitor from Adobe was Adobe Flash, and especially the Adobe Flex software development kit, which is now part of the Apache Software Foundation. Microsoft Silverlight, JavaFX, Adobe Flash, and Adobe Flex. Okay, so let's read a bit about JavaFX. Okay, it says that in Java SDK version 1.3, so the difference is JavaFX 2 versus JavaFX version 1.x. So 1.x primarily uses a declarative language called JavaFX Script to build JavaFX applications, whereas JavaFX 2 and later implement Java libraries, and you write JavaFX applications using Java programming language or other programming languages that run on the Java virtual machine. Okay, and then in version 1.3 there's the font family named Amble, mobile user interface design specialist Punchcut. There's WebView, which is an embedded browser component that supports some HTML5 features, supports HTML5 canvas, media playback, form, history, meter, progress, details, summary, DOM, MathML, SVG, CSS, JavaScript. Okay, and we'll skip this support for mobile hardware, so camera, GPS, Bluetooth, etc. There used to be a JavaFX plugin for the NetBeans IDE. Plugins for Adobe Photoshop and Adobe Illustrator that can export graphics assets to JavaFX Script. Tools that can convert SVG to JavaFX Script. Okay. Began the programming language JavaFX Script started as Chris Oliver's project called F3. Okay, there's agreement with on two technologies for video codec. Okay, so JavaFX 1.1, 1.02, 1.2 Marina, and 1.3, 1.3.1. So this is the final version for JavaFX 1, and it was released in August 2010. The next version, one year later, we removed JavaFX Script, the programming language, and went standard Java. It says JavaFX Script support was dropped permanently in JavaFX 2. Okay, let's go back to the JavaFX script page. So there it says there was IDE support for NetBeans, Eclipse, IntelliJ IDEA. Okay, and the programming language is compiled, statically typed, declarative for the Java platform, so it creates Java bytecode. Automatic data binding, mutation triggers, declarative animation. Using an expression language syntax, all code blocks potentially yield values. Retained mode vector graphics, video playback, and could use standard swing components. So it's compiled to Java bytecode. You can interpret JavaFX script using JSR223 scripting for Java Bridge. You can use any Java classes in JavaFX script and can run on anywhere where there's a JRE, Java runtime. Okay. So let's install enough things on my machine. I'm on Kubuntu 22.10, x86, 64 machine. Let's install enough things such that we can make this sample work. So I started by searching for wiki JavaFX script. And Ctrl-0. I got this interesting result, which was not a wiki page, which is getting started with the JavaFX scripting language for Swing programmers. Super interesting. So it's about JavaFX script, not about JavaFX. It's a programming language that is declarative and statically typed. First class functions, declarative syntax, list comprehension, incremental dependency based evaluation. Makes use of Java 2D Swing GUI components. Allows for easy creation of GUI applications. It says that the recommended ID for this is NetBeans 5.5, which is not that easy to get. And that it has a JavaFX script plugin for NetBeans ID 5.5, which then adds various features to the NetBeans ID, such as a new project wizard for JavaFX apps. Okay, it has a new file of type JavaFX file. Okay, and then at the page JavaFX, in the components, it says that there's a NetBeans ID plugin it says that there's a thing called the JavaFX SDK because JavaFX 1 was not part of the JDK. So you need to install the JDK first and then the JavaFX SDK second. Okay, there's a GUI forms editor, but just for JavaFX 2, so it's not useful for us. Doesn't do JavaFX Script. And then the chapter about history tells us that the newest version that still supports JavaFX Script is 1.3.1. So then I searched Google for this search term. SDK. And it provided these two websites. This being actually a list of binaries that I can still download from the Oracle website. So we have what we're searching for, which is JavaFX 1.3.1 SDK. And the version that I need is for Linux. There's just one possibility, and that's i586, which means 32-bit. So I've downloaded this. In order to download it, I need to create an oracle.com account. So I did that. The next thing is a Java SDK that's from that period. So I saw that Java SDK, Java JDK 6 would be the version that I need. So I searched for the newest version of Java 6 SDK. Okay. So I'm searching for Java 6 SDK. And we still have downloads available. So there's the OpenJDK JDK6 project, or the downloadable binaries from oracle.com. So let's go with those. So it says Linux 32-bit, Intel x86. So this is what I need. This is RPM. I don't know what this thing is. So I've downloaded this binary. It's an installer extension bin. Okay, now let's see if these work and how well do they work. Okay. So I have a bin and a zip file. Let's look at the bin file. So it says that it's a shell, probably bash script. Does it have some help or command line parameters? Does it ask where I want it to download to be installed? This is a binary, Linux elf binary file, probably an executable. So there's -x to extract. I don't know what other command line parameters there are. Let's just execute and see what it does. So I've downloaded this file. which means it's not executable. So let me start it like this. Bash / JDK. Okay, so it inflates a directory named JDK 1.6.0_64, which is a JDK installation. Okay. Let's put this into tilde/.opt. F6. Okay. So JDK 16045, this thing. And then we have the zip file. So let's unzip. It created a directory JavaFX SDK 1.3. readme.html. Let's open this thing with Firefox. The SDK includes the following components: JavaFX desktop runtime, JavaFX Script compiler, mobile and TV emulator, API documentation, and samples. Okay, how do we tell it to use the Java that we just downloaded? JavaFX compiler compiles a source code file. Okay, so let's look at some samples. No, let's create first the Hello World application. Okay, let's create a directory in here. Yes. Shift F4. Hello World. What's the extension for the files? JavaFX Script. I don't know. We'll see it in the samples directory. FX. FX is the extension. File, save as. Lower. Let's rename this thing. Shift F4, FX. Okay. This is the content. Let's remove the extra spaces. Shift Tab. Let's see if Kate has a syntax highlighter for this thing. Highlighting. How do I find what I want? So it's a JavaFX. Is there a JSON in here or something? JavaScript. Java properties. Java doc. JSON. JSP. Let's go with JSON. Okay, ugly. Okay. How do we run this thing? So we need the executable, which is called JavaFX C, this thing, F3. So it's a shell script, uses the same arguments as JDK's Java C command. Okay. How does it find Java? Java command is java home/bin/java. If exists Java home. Which Java? If it does not exist, then it does which Java. Okay. So we need to put Java, the first thing on the path, environment variable. Okay, so let's prepare that. So export path equals so we need this thing. Control A, Control C, Control V, Control Shift V, Control S. Okay. And but then, is this an executable? Yes, it is. So we can put this thing also on the path environment variable. Let's see if this thing works. F6 JavaFX SDK in this directory. Control V. Okay. So I need to create a new tab in console. Control Shift T. Echo sign path. Okay. So the environment variable path starts with the directory that contains the JDK binaries, so Java binary and Java-C, continues with a directory where there are the JavaFX SDK binaries, so JavaFX, which is the runtime, and C, which is the JavaFX C, which is the compiler. So let's go Java minus version, nothing, Java minus version works okay. And then JavaFX C version, and it works. So it's JavaFX C 131 minus B01. Okay. And this is the help for JavaFX C, and the help for the Java compiler should be similar. So minus G generate all debugging info, minus G none, minus G lines var source, no warn verbose deprecation, class path CP, source path, boot path, x dirs, e endorsed dirs minus d, and then there's minus proc processor and minus processor path. Minus d is common, minus s is additional implicit encoding target. There's a minus source, edit to Java-C. Okay, so it seems that we have downloaded correctly the JDK, Java Software Development Kit, and the JavaFX Software Development Kit. I have unzipped those, put them in tilde/opt in their own directories. I have edited the path environment variable correctly, put the Java binaries directory first and the JavaFX SDK binaries directory second. And now we can start working with the source code file. Okay, PDS and list. So there's hello world fx. Let's delete hello world txt. Okay, let's look at hello world fx file. Looks okay. Let's compile it. How do we do that? I know. Okay, it did not complain, so that's a good sign. In Unix, if an executable like command line does not return anything, it might be successful. Okay, so it created a file named helloworld.class, which is a Java compiled bytecode file. Okay, let's get the Java decompiler and see what's inside. Java decompiler. This thing. jd-gui download. Okay. This thing. Input. Save. Let me run this thing. So Java minus jar Control Alt C Control Shift V. Okay, and says unsupported major minor version 52. Ugly. Let's use another version of the Java virtual machine, the JDK. So JDK 19. /Java, and I need a terminal in this directory too. Ctrl-Shift-D, CD, Ctrl-Shift-V, Java -jar, and then jd-gui, Ctrl-Alt-C, Ctrl-Shift-V. So this doesn't have both. Okay, the bad command line. Okay, let's decompile what JavaFX the JavaFX script compiler has generated, which is the file hello world.class. Ctrl-Alt-C, open, Ctrl-V. So there's the source code file. Hello world.fx. How does it know about this file hello world.fx? And how can we view it? Okay, so hello world.class has been decompiled. There's just one class in here, which is called hello world, which extends fx base and fx object, which come from the internal class, so not public class, which is called com.sun.javafx. So JavaFX packages are public packages, whereas com.sun.javafx are internal private packages. These are not part of the Java API, and their implementation, their interface, etc. can change from one version of the JavaFX SDK to another. Okay, so extends fx base and fx object. There's a integer array, another integer array. There's the constructor, which says this for, so it calls the other constructor, which then calls super, which is the constructor from fx base. What we have? Go to definition there. Type open type hierarchy. Okay, and then it calls initialize, and then initialize does what? There's no method called initialize, so it must be from fx base probably. There's a static block. Okay, let's see what this method does. So it's called JavaFX run, and then sequence extends string param sequence, and returns an object, static and public. I can see the string hello world in here, so it says case for text set content hello world. There's a JavaFX scene, get map, scene, sequence, stage, okay, so scene and sequence and stage seem to be central objects, types in here. JavaFX scene. There's also fonts, which are actually font, which is actually what? JavaFX scene text font. So there's a special type for font. It doesn't reuse types from AWT or from Swing for font. There's text, which is what? Text is the child of scene, JavaFX scene text. Yes, in here. So it's a package, the lowercase text. And it contains the type font and the type text. It sets a font to the text. It sets a content to a string. It applies defaults. So text seems like it's the label in JavaFX script. This is an engine and a renderer, a state machine. So everything is converted to a class. And then there's absolutely no magic, because there's no external engine that interprets the FX files at runtime. You're just left with this .class file, which you can easily decompile back to Java and see exactly what your application does. Again, this is okay because there's no magic. Yes, there is this separation between data, which is the hello world.fx file, which is a DSL domain specific language. And then there's the engine that interprets it. But then both the data and the engine get compiled to bytecode, to Java bytecode, which is this source code that's clearly being generated. People don't write this type of source code. But again, because we have this intermediate representation, this class, we can see exactly what it does. We can even put a breakpoint in here and use a debugger to see how the items inside hello world.fx are actually rendered to the screen, how they're repainted, events, everything can be seen here. Okay. So we did the sample hello world, but we did not run it. Let's run it. Where are we? In here. So how do we do this? Java no class def found. Com sun JavaFX runtime fx object. We need a main from somewhere. Okay. I need to research this thing. Just a second. Okay, so I have run I try to run Java and then the name of the class file, so Java space hello world. It complained that there's no main function. I went back to the tutorial, and the tutorial says that it starts Java space then the main class on net.java.javafx.fx shell, and then space or as argument hello world. So I tried that, but then it could not find. Where are you? Could not find the package net.java.javafx.fx shell, and then I remember that there's the JavaFX executable, which is actually the runner for so JavaFX C is the compiler, takes a file with extension .fx and converts it to at least one file with extension .class, whereas JavaFX allows me to run the build .class file. But then this is 32-bit, so Java is 32-bit, Java C is 32-bit, JavaFX is 32-bit, JavaFX C is all the Java things are 32-bit. And this is trying to use com.sun.javafx.runtime.main.main, which then needs libx.ext.so.6. Obviously, it cannot find this .so file because this SO file is for 32-bit, so it's an ELF binary dynamically loadable shared object Linux, but for x86 32-bit. So I need to install this .so file. For that I needed to go the package -add -architecture i386 apt update. Then I searched for the file. I said which deb package contains libxx.so.6, so apt-file find, and then the name of the file on the hard disk, and says that the package is named libxx6, and this is where the file will be on the hard disk after it's being installed from this deb package. So then I say apt install the name of the package, colon the architecture, so i386, says it could find it, and there's a number of packages, dependencies, the packages that will be installed, including libx11, libxau, xcb1, xdmcp6, etc. So I say yes, install all this, pollute my hardware operating system installation. So this suggests that I should have installed a 32-bit Linux virtual machine and do my experimentation there. Okay, so let's run again JavaFX space, and then the name of the dot class file, so hello world. Now it complains about libxtsd. So let's do this too. Okay, so this thing apt install i386. Okay, libxi. libxi6. Okay, next. Ooh. JavaFX delivers rich media, so the fonts are ugly. Totally do not look okay, and not the icon does not look okay. There's bad pixels everywhere. Okay, so JavaFX delivers rich media and content across all the screens of your life. So this L is too wide, this L is too narrow. So it's totally JavaFX was meant for rich media, so rich internet applications across all the screens of your life, so TV, mobile, tablets, desktops, etc. So convergency, which means scaling, which means not just mouse input, but also touch input and gyroscope and accelerator and compass and all of the other hardware input-output devices on mobile phones. The application you have selected requires you to install the JavaFX desktop runtime from Oracle. Okay. By clicking the accept button, you acknowledge that you have read and accept. Yay, hello world. Okay, so that was a EULA. Just the first successful run of the application has shown that EULA end user license agreement acceptance GUI dialog. The next runs did not show the EULA dialog. Okay. What other cool things can we do with JavaFX script? Okay, so let's do the second Hello World application. So we'll do 2. And what's the name of this thing? Still Hello World, Shift F4, Hello World dot fx. Okay, and the content is this thing. Copy, Ctrl V, and Shift up. It says import JavaFX UI everything, so it imports everything from the JavaFX UI package. Creates a frame, which is probably a window, that has the title Hello World JavaFX, as given width and height, and inside there's a label with the text Hello World, and that's visible. Okay. This uses just stage, scene, and text, whereas this uses JavaFX.UI, which is for frame and label. So this is probably the low-level bits, whereas these are the desktop, similar to q-quick controls, whereas this is similar to the low-level painting, the low-level primitives in Qt-Quick. Okay, Control S, jd-2, and JavaFX Hello World. Says class not found, so you cannot just run JavaFX and then the name of the fx file. You need to do 2 steps. So JavaFX C, and then JavaFX Hello World. Invalid assignment with 20. Package JavaFX.UI does not exist. What do you mean? JavaFX UI, there it is. So it could find JavaFX.stage, which is I'm not sure where JavaFX.stage is. Probably in JavaFX common. Okay, maybe I need to pass as parameter to JavaFX C the packages, the other Java jar files except JavaFX common. Specify where to find user class files. Override location of installed extensions. Okay, so I have found the solution. So the example was import javafx.ui .asterisk, and then it tries to import from there the type frame and the type label. Okay, so how do I do that? I open the Java decompiler, I close all of the opened jars, And then I go to the JavaFX SDK installation, and I find all of the relevant jar files. So Ctrl S states.jar. Jars are inside lib, not inside emulator, not inside samples, just inside lib and not inside Prism or TV or mobile, because my mobile is CLDC and we're not using this profile of Java. So there's only desktop and shared. Let's go to desktop. We select all of the jar files. We drag them to the Java decompiler, and the rest of the jars live in the lib shared directory. We drag all of these, and then we use the search button to search for what we want. So we want to search for frame, search for type, and there's no such thing as JavaFX.ui. .frame. Okay, so this is for assembler. This is for no Boolean class object reference, something very low level. This is frame, file open dialog. This is window, but it's from java.auth, not from javafx.ui. Then there's javax.swing.jframe, not frame. Again, not from javafx.ui.frame, but javafx.swing.jframe. So the only thing that comes close to this is JavaFX -UI -swing. .jar. Label. So there's the java.auth.label class for label, and for frame there's rt15.jar, java.auth, and window class. Okay. So then it turns out that there's no such thing as the package JavaFX.ui in JavaFX. It says the JavaFX.ui packages contain an older version of JavaFX, a prototype of JavaFX UI classes, which existed before July 2008. So these pages that talk about java.ui are for the version of JavaFX that were never released. So for versions of JavaFX prior to being released, they renamed a number of packages. Where is it? History. So it was announced in May 2005. It had some a structure for packages and classes. Then in May 2008, it announced that they will be available in the third quarter of 2008, and they renamed again things because they didn't have a release, so there was no API, application programming interface guarantees that they needed to provide. And there's no JavaFX plugin for NetBeans 5.5. They released, so the released version of JavaFX had a plugin, but for NetBeans 6.1. Okay, so this entire tutorial that I have been following is for a version of this one, is for a version of JavaFX that predates the first public release. So the first public release uses different UI, different ID, different everything than what's documented here. So this page is less than worthless. It's actually misleading people. There's no JavaFX.ui, there's no frame, there's no label. Whereas the wiki page for JavaFX Script is correct. So there's such things as JavaFX stage, scene, and stage being probably a renamed java.auth.window or Java rename of JFrame. Okay, and label was probably renamed to text and moved from javafx.ui to javafx.scene.text. Okay. There's other tutorials on the internet that use the namespace Java UI, javafx.ui, but all of these are old things that never worked with the version of JavaFX that was publicly released. Which is a shame because there's a ton of tutorials here. So absolutely all of them use JavaFX.ui. In this Scriptlandia lang examples, JavaFX. And even we can see that the last commit is from December 2, 2007. Which is before the Q3, so before JavaFX 1.0 was released in 2008. Okay, so we totally need to ignore these examples before the actual release of JavaFX. Okay, but now at least we know exactly what's the API surface of JavaFX. We just open all of the jar files in Java decompiler and we see there what's available and what's not available. So this sample is wrong. This sample with frame is also wrong. So this shows the procedural way of writing JavaFX script files, and the other one with similar structure to JSON. That's the declarative way of writing JavaFX script files. Okay. There's a package, there's such a thing as the package javafx.x.swing. We can see it if we search for swing frame. Where was it? rt.jar, JavaFX swing, and where is it? This thing. So there's swing frame. Not really. And label is named swing label. JavaFX X swing. Everything smells like a work in progress in here. This is the second paragraph text. The fact that this thing does not exist, or this thing. So it only existed for 2 years and none of the samples work. And nobody can correct the samples on the internet or in Wikipedia because nobody actually remembers or has a development environment to test if these samples actually are any good. Cannot find symbol swing frame. Yes, there's no swing frame. There's a swing label. No swing frame. And there's no need for any swing frame because the swing frame in fact is the stage. Let's actually write this sample application but correctly. F7, 5. So it says that this thing is, how do we comment out? So this is the declarative way of writing JavaFX script, and we need to convert this thing to a procedural way of programming. So this thing line by line with no curly brackets. So there's a swing label. And what else? JavaFX UI. Probably need from auth. Let's use the stage. Stage. And for stage we need this thing. Okay, if import swing everything, might get access to swing label. Okay. Does the swing label have text? Lowercase t. No, it does not have such a thing. This looks like compiled source code. The source code that was compiled using JavaFX C. Yeah, totally. I don't know what these things are. Examples or something. Yeah, it's the exact same thing. So this is the result of JavaFX C, the JavaFX compiler. So this will not work in any way. So we'll end up editing the JavaFX script wiki page. Let's do that. Okay. JavaFX script declarative syntax for constructing user interfaces contrasts sharply with a more verbose series of method calls. So it's using a stage, and instead of a label, it's going to use a text. And for text will use this. So label has a text. No, it has a content. Okay. What about the stage? Does it have a width and a height? Yes. Does it have a visible? I'm not sure. And then content, my label. This could work. This is a procedural style. JavaFX Script. And this is declarative style. Okay. Let's try to compile this thing. Okay, so it doesn't have any content where to put the label. Let's find out the exact API. So javafx.stage.stage. Where is stage? I don't know. So this was also compiled using I know. Okay, so stage. Does it have a content? $sign title, $sign visible. So it I called visible and it didn't complain. So visible is okay. Width and height. Width in here and height in here. There's full screen. Visible. Label. The label is text. In this thing. In common. Text. Okay. And it has a member named content of type string. Correct. But then what about stage? Stage, what members does it have? Scene. The only thing that could be there could be a scene. And indeed, stage contains just one member named scene of type scene. So with the title, width, height, and it's not called yeah, we didn't put the title yet. Let's put the title. So let's make this thing lowercase stage. Make this lowercase text. Let's do the text first. Text. Content, I can see it in here. Actually called content. And X and Y. How come the text has X and Y? Okay. X10. Y30. So I did the text. Now I need to do the scene. Scene. Okay, the scene has just one thing, a content. The content is the text. Oh. Let's make this my. Okay, so I did the text. I created a scene. And says my scene content equals text. Okay, so I put the text inside the scene, and now I can create the stage. Okay, my stage. Title, width, height. Semicolons. Okay. Title, width, height, and scene. And this is my scene. Okay, let's try now. Cannot find scene, yes. It's not imported yet. Okay, we're back. So we have the same program into JavaScript, JavaFX Script styles. So there's the declarative style and the procedural style. The procedural style is many statements that end with a semicolon, whereas the declarative style uses blocks separated with curly brackets. Okay, let's look at the current state. So this is the application in procedural style. The difference from the declarative style is that I do not set the font size. If I do set the font size, it complains that the property size, or the attribute size of the myFont object is has default access, write access from script only. I do not know exactly what that thing is. So let's look at the definition of dot font. So I have made the conversion from declarative style to procedural style. The way it ended up is we have the same block of import statements. We have the same number of objects, so one stage, one scene, one text, one font. Okay. The name of the object that I create is my, and then the name of the type. So font is name, the name of the variable is my, and then uppercase f, lowercase ont. In procedural style, I'm specifying a variable declaration and the type. So I get go var space, the name of the variable colon type equals, and then either I call a constructor, which is what the declarative style does, or in the case of font where the constructor is only available to declarative style, is not available to procedural style, I need to call a static factory method that goes requires the name of the font family and then size. Let's see the end result. So it's the same result as when I'm running the declarative style one. Let's actually check this. I'll comment out the procedural style, uncomment the declarative style, Ctrl S, and it's the same thing. Let's eventually make a screenshot of this thing. Take a new screenshot. Copy image to clipboard. Imp. New template A4 landscape. Ctrl V. Okay, now let's comment out the declarative style. and uncomment out the procedural style. Take a new screenshot, copy image to clipboard. So they really are identical. Same font, the same window size, the same window title. The text is different. So I did not copy the text correctly. This should not have had an exclamation mark. Okay, so I declare a variable of type font named my font. I call a static method, which is this one. So I search for the, so this are all of the jar files that are part of the JavaFX SDK 1.3.1. I'm searching for the for this type. Does not work. I'm searching for this package. How do I do that? Okay, let's search for a relative, so a type that's in the same names, in the same Java package as font, which is text, and it has found it. So it's in JavaFX -ui-common.jar. The com.sun packages are implementation details, whereas JavaFX.scene packages are public JavaFX SDK 1.3.1 public API, application programming interface. Okay, so I expand the jar JavaFX -ui-common.jar. I expand the package JavaFX.scene, the package text, and I get to the text class. This takes me in JD, the Java decompiler. Hit this place, text class. And in the same package, there's a font class. I'm not sure why searching for the font class does not work, but does not work, search does not work. But JD, the Java decompiler, found the font.class file, found the class font, and we can look at its source code. Okay. So what it did not allow me using JavaFX Script procedural style to call the constructor with 0 parameters, which is this one, and then call the JavaFX property attribute size, which is 24 in this case. So size is actually a this is actually the backing store, so the property, the field, the member variable is of type float. It's named $size and has 2 accessor methods, which are standard for implementing Java properties in Java. So there's a get size, so lowercase gt, and then the name of the field, which is $size, just returns the data member field. And then there's set size of type float, and it actually does a ton of heavy lifting. Okay. Set size. The setter is not protected against being used from JavaFX Script procedural style, but the member variable is protected. So $size says that it's script private, and because it's script private, the compiler will return the error. Size has script only, says script private. Default write access in javafx.scene.text.font, which is the type of this member variable. Okay, and from script you access it using size, not $size. It says in here source name. Okay. So with that, we know how to edit the wiki page for where are you? The wiki page for JavaFX Script syntax, and I'll edit it to not contain javafx.gui, javafx.ui, or the swing, frame, button, etc. classes, because those are not available in the release version of JavaFX. So we can look at JavaFX UI swing. So there's just one public class there, javafx.stage.alert, whereas the wiki page uses way more. Goes javafx.ext, which we do not see. Let's look at all of the jar files. So this is private, 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 private, private. Just two packages. None of them is javafx.ext. Private. No javafx.ext package. Private, private, and JavaFX FXD package. There's no javafx.ext here. Not here. Not in Java UI common. There's no javafx.ext. Okay, this is javafx.scene.chart. This is private implementation detail. JavaFX.media. JavaX. Private. Private. JavaFX stage. Private. Private. This is for HTTP requests. JavaFX Script. RTjar. So there's no JavaFX names package in rt15.jar. Neither here. JavaFX.ext does not exist in here. Private. No JavaFX.ext. And private. So none of the jar files that come with JavaFX actually contain the package javafx.ext. There's no such thing. So there are some tutorials for JavaFX Script. Most are from around the year 2008, and a good chunk of them use JavaFX SDKs, which were pre-release versions, so not the release version, but JavaFX SDKs prior to the release of JavaFX 1.0 SDK. So you will need, whenever you look at JavaFX Script tutorials, to make sure that those tutorials do not use JavaFX.gui, JavaFX.ui, JavaFX.ext, and then for all of the other packages and classes, you're going to need to load in Java decompiler JD all of the jar files that exist in the version of the JavaFX SDK that you use, and you should always use the latest one, which is JavaFX SDK 1.3.1. This is the newest that still has support for JavaFX Script. Okay, so take all of the tutorials with a grain of salt, that maybe they were written with a JavaFX SDK version prior to the first public release, which is 1.0. Okay, then there's a very interesting web page that I found. Which is this page, which says that there's declarative style versus procedural style. The declarative style for this stack of 3 blocks says a tower of 3 blocks, whereas the procedural style says put down block A, put block B on top of block A, put block C on top of block B. Okay. HTML can declaratively specify a view hierarchy. So it says div, inside there's another div, inside there's a button, inside of the button there's an EMG with cut.png, and then there's the cut text, and then and this div, the toolbar one, and another text area ID editor. So this part is the text area. Okay. Declarative HTML versus procedural Java. So in Java Swing, procedural, so file with an extension .java, so Java source code, you'd go jpanel main new jpanel, jpanel toolbar new jpanel. So first you create objects and then you connect them. So you go main, which is the panel that contains everything, .add toolbar, and then you go main.add editor. And what's editor? Editor is a JText area, editor new JText area. So the toolbar will be on top, it's just a JPanel, and then on the bottom there will be a JText area, which is a multi-line text editor, text entry. Okay, and then inside of toolbar you go add button, and button is a JButton, new JButton. You set it an icon and you set a label. Okay. Even in HTML, you could have declarative HTML, and then you could go procedurally in JavaScript, edit the document object model, shortened DOM. So you go div id main, that in JavaScript you go document, which is the DOM, the entire web page, dot create div. So this is the same as left than div, and then id equals main, you go main, which is the div, set attribute id and window, so pair of id and window, so id and window. Then you go toolbar, so toolbar is a div, document.create element div of type div, and you name it toolbar. And then you will need to put id and toolbar, so go toolbar, set attribute id and toolbar. And then you're going to create a button, so this is an actual HTML tag. So go document create element button, you store it in a variable named button. Inside you will have an img, so go document create element img, you assign it to the variable img, you go img set attribute src cut png, and then you start appending, so you go the button append child img. Okay, then you create the cut, which is the text. So you go document create text node cut and button append child label, which is the actual text HTML element. And then you finish up connecting things. So you go button dot append child label, so for the cut, toolbar dot append button dot append child button, and main, which is window, where is main, not window, append child toolbar. And then you do the editor. This is a text area, so document create element text area. Then we set the ID, so editor.set attribute ID editor. And then window append child editor. So window being main, you add inside of it this HTML part, so text area ID editor text area. Okay, so this is procedurally in JavaScript, and this is declaratively in HTML. Okay, you can mix declarative and procedural code. You create just the div ID main and the text area, so the toolbar is missing. So then in HTML you create a script block where you say document create element div ID toolbar. Then you create a button using inner HTML. So the outer HTML is div and then the attribute ID equals toolbar. But the inner HTML is all of this part. So button, img src cut, img cut, and button. This is what it does. So button ends in button, img tag ends in img, src cut, and the text cut. Okay, and then you hook everything up. So you go main insert before, inserts toolbar before editor. Okay. And the advantages and disadvantages of declarative UI is that declarative UI is usually more compact, and it's also most of the times indented, so you can see which control is a child of which control. So in our example, you can see this indentation where it says that these are the members of the object stage, and these are the members of the object scene, and these are the members of the object named content. Not named content, but the attribute named content of this object. So actually the objects don't have names in here. So we know just the type of the object and values for some of the properties, attributes of the object. That's why in procedural code I named all of the variables my and then the type, because in declarative style there's no names for the objects. The objects do get created, we know their type, they get created with default values, and then we change the default values by assigning values to attributes properties, so title, width, height, and scene. Again, an empty scene is constructed using the default constructor, and then we use the content property of the scene to change whatever is inside. Okay, so this is what we put inside. Again, an anonymous object of type text with 4 properties being changed. One property requires another object instance, unnamed, of type font, and this instance has just one member with a value changed using a property. Okay. So it's easy to read because it's indented. There's less source code because there's no semicolons, there's no new keyword, there's no variable declarations, there's no variable name. Okay. So usually more compact. It totally is more compact in the case of JavaFX Script. This is more lines than, or more characters than the declarative syntax. Programmer only has to know how to say what, not how. So there is an engine that looks at the declarative code and does the right thing. So it puts the controls in the correct places on the UI. If it's a desktop application, it will create a main window. If it's a watch application, so an application that runs on a smartwatch, it will do something else because there's no free floating windows on smartwatches. So automatic algorithms are responsible for figuring out how to actually instantiate everything. We only say what we want instantiated. It's totally harder to debug. There's no breakpoints, there's no single step. So in Qt framework's QML programming language, you can have JavaScript methods and event handlers, etc. So you can have JavaScript procedures, and inside of those procedures, functions, you can put breakpoints. So you can debug the JavaScript part, but you cannot debug the part that is purely declarative. So where you say, create me an anonymous object of type stage and set its or bind its property. Okay, so cannot set breakpoints, cannot run it in a debugger, the purely declarative part. Cannot single step, cannot print in a declarative specification. In QML, you can actually, where you bind, so the right-hand side, you can replace the right-hand side from an int, in this case, with the call to a function. And that function will return type int, will return the value 80, but then you can do extra things inside of that JavaScript function, such as you can print, so you can go console.log something. So this is the print style of debugging, where you print things to standard output. Debugging may be more trial and error. Yes, it's totally trial and error. The vast majority of people working on QML try a ton of things until they find something that actually works, looks correct, and works correctly. Okay, authoring tools are possible for declarative UI. There's totally UI editors for HTML, for Microsoft.NET XAML, whereas creating GUI editors or forms editors inside of the integrated development environment for this type of thing is way harder. And the problem is that whatever the forms editor generates should not be edited by the programmer. So this should be in a block that says auto-generated, please do not edit. Otherwise, the forms editor will know how to generate this block, but if you intervene and put random source code in here, the forms generator will not know how to read this thing back, the source code, and present in the forms editor. Okay, so authoring tools are possible. Declarative specs can be loaded and saved by a tool. Procedural specs generally can't. Programmers, when they see procedural code, they have the instinct of going in and editing. When they see declarative source code and that's in a block where it says automatically generated, or maybe in a separate file that says automatically generated, then yes, you will not actually edit that by hand. You will use the form editor inside of the integrated development environment. Okay. And then it goes on to talk about HTML, CSS selectors, declarative style versus procedural style. Go button.style.border equals 2px versus the CSS block button, curly brackets, border, colon, 2px, semicolon, curly bracket, close curly bracket. Okay, there's other declarative UI languages. Zool used by Firefox, XAML used by .NET. And immediately after you have declarative style programming and there's a separation between what the programmer wants and how it's actually implemented, you immediately can start implementing model-based user interfaces. So the motivation is adapting to change, particularly for devices and users. So you might have the same application work, so the same source code, and then render differently. The rendering engine that understands the declarative syntax will render differently the GUI at runtime for a watch, for a smartwatch, for a smartphone, for a laptop, desktop, wall screen, and other form formats such as TV controlled with the remote. Okay, the widgets available will be different, and even might not use the same cross-platform toolkit everywhere. So it might not paint a button. Instead, it might see the engine might see that it's running on Apple iOS, on an iPhone, and then it will use the default button implementation in iOS. Okay, so the widgets that are going to be shown on the desktop might be non-native and portable and actually created using a scene graph, a painter, so the engine will paint lines and curves and fonts, or might the engine might actually decide to use natively available widgets. Okay, then the input style is totally different from a desktop computer versus a iPhone. So on the iPhone you will probably flick and pinch and scroll with your finger and touch with your finger, versus on a desktop computer you will probably use a keyboard and a mouse. On a TV you might have speech, so you might speak to your remote control, or you might have the D-pad on the remote control, the left, top, right, bottom buttons on the remote control. You might use a pen. Okay, output style, it might not have any GUI at all. It might just be speech style, or it might not be GUI. It might be TUI, text user interface. It might run on the command line versus display. Okay, so the engine has some room for what it actually does, how it actually renders the declarative source code. Okay, so the programming is done at a higher level. You rarely do on paint method. You implement the on paint low level event. Okay, the system, which is the engine, generates actual presentation, windows, tabs, panels, widget selection, layout, etc. Okay, model-based user interface is declarative and also abstract. The user interface can be adapted automatically to different situations. Programmer provides a high-level description of the user interface. The model is a plain old object. It might contain member variables, so data. So the model for a login dialog box might have just two string variables, a username and a password, and just one method, the method login. So if you have the model, which is a class that only has two properties, username, password, and one method named login, you might reuse this model class for a text user interface application, for an application that actually is not text user but interface, so it doesn't paint the entire screen in the terminal, but it just prompts on standard output, please enter a username, and then it reads from standard input the username until the user presses enter, and then it writes to standard output the string password, and then it waits for the user to enter a password and press enter. Okay, so that's a command line application. Or you might have a web application, or you might have an iOS application. Everything is possible if the backend source code is just that, 2 strings and a login method. The way that you create the user interface, you have a large amount of freedom when you create the user interface if the backend is just that, 2 strings and a method. Okay, and then there's a description that goes from the model, which is this simple class, to what actually happens on the screen. So you might say that the username string variable, member variable, will be represented by a text field, a text area, a combo box. The command method login might be a button, a main menu item, a keyboard shortcut, a voice command, etc. On the presentation side, you might style your controls, your UI controls, so you can set font colors, font and color. So programmers need to specify the presentation, so the mapping from the model class to the actual UI. Okay. So the app can adapt to many forms of form factors, hardware, data entry, data output. Okay, and there's a correlation between declarative programming languages and model-based user interface, and then there's a correlation between declarative UI style and animations. There exist animations both in JavaFX and in QML. Okay, so declarative says what and how is the how is up to the engine. There's a separation of structure and presentation. Okay, and you have the override that procedurally you can do and change all of the things that you can do in a declarative manner. Okay, let's find some more examples and some extra tutorials. So there's this tutorial that says functional programming and procedural programming provide different views of the same thing. When I declare this, y equals 2x, in a procedural way it says let's declare a variable named y, let's assign it or initialize it with the value of 2 times what's stored in the variable x. Whereas in a declarative style, you might say that this is the function f of x, and it has the value 2x. So the graph would be something like a linear graph on the OX or Y axis. Infinite line on a graph. Both are useful and constantly used. In JavaFX Script, there's a bind operator for functional relationships. So whenever the right-hand side changes, automatically the right-hand side, the left-hand side will be called. So this property or attribute will have its value changed. In the background, there might be a property watcher that sees if the value of the property X has changed. There's also the possibility of animating, which means that there's a OT axis, so the time axis, and as time changes, state will change. So properties will change based on lowercase t, the time. Any JavaFX script variable may be animated. Animating a variable amounts to assigning it a new value to it often enough to create the perception of continuous change. Often enough needs to be at least 60 times per second, depending on how the human eye discerns between two states of the animation or not. Okay. In computer animation, we use the system invented by traditional animators. So from the cartoon authors, and the programmer in JavaFX Script is the animator and specifies key states of a variable at various points along the time dimension. Provides an interpolation function to automatically compute the in-between states. So there's a functional function that decides what are the values in between states, and we say the key states. So we say when it's here it should be red, when it's here it should be blue, and the color changes from here to here as time progresses using this function. Okay. An animation can target any JavaFX script variable, but we could have just one value be changed by the animation, one property, and other properties could be bound to the first property. So there's an animation that changes property X, and property Y is bound to the property X. Okay. So for instance, we can animate just the width of a rectangle, and then width times 2, on the right hand side, is bound to another property of a rectangle, which is called height. So height increases with twice the speed of the width. So it becomes higher and higher relative to the width as time passes. So it's animated over 1 second. There's a keyframe at 1 second and at 0 seconds. There's just 2 keyframes. So it starts at 0 seconds, ends at 1 second. And then for 60 frames, we don't know exactly what the values are. But we have functions that compute that thing. So it says that at the second 0, the width will be 100, so hard-coded. Whereas at the final keyframe, at the second 1, which is the 1000 milliseconds, the width will be 200 twin linear. So it does linearly interpolated in between using twin. And it ends at 200. Doesn't go past 200. And then there's the method play that actually starts the animation procedurally. The code only animates the width variable. The height variable is bound to twice the width and is animated at the same time. So whenever width changes, height changes automatically. So both height and width will animate in the same frame. Okay. The rectangle is defined at height, width, and fill. And we need to put that thing in a stage scene in order to have a JavaFX script window. Let me try to see if I can actually create the source code for this thing. So I have discovered how to put more than one element inside of a scene. So let's look at the source code. So it says JavaFX -UI -command.jar, package JavaFX scene, class scene, and in there's a content property. So $content exposed in JavaFX as script as content, and says sequence of node. So by default in here was just content and then a text. So I guess that a node is a valid instance of sequence node. It's a sequence of just one node, so there's no need to actually use JavaScript JSON syntax for arrays. Let's find this thing out. Okay, so content is the property, has just one parameter, sequence of node, and we could have a sequence, so square parentheses, and then one instance of one object of type node, which is probably an interface. Let's see how it looks like. Okay, so there's just one element, just one element in the content. So might use a array with just one element, or you might omit the square parentheses, as in this case. There's no square parentheses here. Okay, for more than one element, yes, square parentheses are mandatory in order to specify that this is an array. So we have an array of two texts. The text is a label, a read-only text, so label. There's two labels, and one starts at y. So the y goes from top to bottom. So this is 0 pixel y, and this is 1, 2, 3, 4, 5, and this is 30. And then 60, 70. In here will be put another label. Control S. Yes. Okay, so at coordinate 30 starts the first label, and at coordinate 70 on the 0 y-axis is the second label. Okay. Then we'll need to add such a thing. So we leave one label and replace the second label with a rectangle. Okay, we'll not bind anything to make sure that the rectangle appears. So make the rectangle 100 by 200, Control S. Make that at y. We don't know the y. 100. Okay, let's see if this thing works. It says it doesn't know what is a rectangle. Let's try to find it. I guess in common. JavaFX scene shape rectangle. This thing. Import Ctrl V dot rectangle. Okay, cannot find symbol blue. Okay, I don't know how rectangle specifies the color. There's no fill property. So I'll be back in a second.